Hey y'all, this is Ishnai Laboratories and welcome to my stream. We're gonna go ahead and start, of course with the the space stuff, but hope y'all are doing well. Okay, this is from the BBC. Cave discovered on moon could be home for humans. Woo! Scientists have speculated that lunar pits like this one could be cave entrances. Now they have proof. Scientists for the first time discovered a cave on the moon. How long has it been? At least 100 meters deep, it could be an ideal place for humans to build a permanent base, they say. It's just one in probably hundreds of caves hidden in an underground and undiscovered world, according to researchers. Countries are racing to establish a permanent base on the permanent human presence on the moon, but they'll need to protect astronauts from radiation, extreme temperatures, and space weather. Helen Sherman, the first British astronaut to travel to space, told the BBC News that the newly discovered cave looked like a good place for a base and suggests humans could potentially be living in the lunar pits in 20 to 30 years. But she said this cave is so deep that astronauts might need to abseil in and use jetpacks or a lift to get out. Lorenzo Zona and Leonardo Carrier at the University of Trento in Italy, I say as a quarter Italian person, found the cave by using radars to penetrate the opening of a rocky plain called the Mare of Tranquillitas. Hey, Wolf, how are you? It is visible to the naked eye from Earth, and also where Apollo 11 landed in 1969. Nice. Sorry, bad joke. The cave has a skylight on the the moon surface, leading down vertical and overhanging walls, and a sloped flooring that might extend further underground. It was made millions or billions of years ago when lava flowed on the moon, creating a tunnel through the rock. Closest equivalent on Earth would be the volcanic caves in Lazarite, Spain. Professor Carrier explained. Carrier explained, adding that the researchers could visit those caves as part of their work. This is the idea of creating basically where humans can live on the moon more safely because it's kind of out of radiation. And it probably will have more stable temperatures. Relatively. It's really exciting when you make these discoveries and you look at these images and realize you're the first person in history of humanity to see it, says Professor Carrier. Once Professor Bronzel and Professor Carrier understood how big the cave was, they realized it could be a good spot for a lunar base. After all, life on Earth began in caves, so it makes sense that humans could live inside them on the moon. The cave has yet to be fully explored, but researchers hope that ground-penetrating radar, cameras, or even robots could be used to map it. How's my sound, by the way? And also, how are you doing? The cave is yet to be fully explored, but researchers hope the ground-penetrating radar, cameras, or even robots could be used to map it. Scientists first realized there's probably caves on the moon around 50 years ago. I mean, you're allowed to be, to some degree. Things aren't going so well. I mean, you're allowed to be grumpy and an asshole as long as you don't take it too much out on other people. We have very good images of the around 50 years ago. Then 2010, a camera on a mission called the Lunar Reconnaissance Orbiter took pictures of a pit that scientists thought could be cave entrances. Kind of grumpy for no reason. I mean, that's fair. Sometimes you end up being grumpy for no reason. But researchers did not know how deep the caves might be or if they had collapsed. The professor's work now answers that question, although there is much more to be done to understand the full scale of the cave. We have very good images of the surface, up to 25 centimeters of resolution, and we can see the Apollo landing sites, but we know nothing about what lies below the surface. These are huge opportunities opportunities for discovery. Francisco Sario, coordinator of the topical team planetary caves of the European Space Agency. I'm good with words right now. I'm reading them aloud. Everything goes well. That could open the door to finding evidence. The research also may help us explore caves on Mars in the future, he says. That could help open the door to find evidence of life on Mars, because if it did exist, it would be almost certainly have been inside caves protected from the elements on the planet's surface. The moon cave might also be useful to humans, but the scientists also stress that it could help answer fundamental questions about the history of the moon and even our solar system. The rocks inside the cave will not be as damaged or eroded by space weather, so they can provide an extensive geological record going back billions of years. The research is published by the Scientific Journal of Nature Astronomy. All right. Mercury has a layer of diamonds 10 miles thick. NASA's Messenger mission has revealed that Mercury, the solar system's tiniest planet and the closest to the sun, hides a big secret. Now everybody will want to finally, go to Mercury now, pay attention, because there could be profit. The solar system's tiniest planet may be hiding a big secret. Using data from the NASA's Messenger spacecraft, scientists have determined that a 10-mile thick diamond mantle may lie between the crust of Mercury, the closest planet to the sun. Please, heavy Minecraft. I know, right? Mercury has long puzzled scientists as it possesses many qualities that aren't common in other solar system planets. These include its very dark surface, remarkably dense core, and premature end of Mercury's volcanic era. Also, among these puzzles are patches of graphite, a type or allotrope of carbon on the surface of the innermost planet of the solar system. These patches have led scientists to suggest that in Mercury's early history, the planet had a carbon-rich magma ocean. This ocean would have floated to the surface, creating graphite patches and the dark shaded hue of Mercury's surface. The same process would have also led to the formation of carbon-rich mantle beneath the surface. The team behind these findings think that this mantle isn't graphene as previously suspected, but it's composed of a more precious allotrope of carbon, diamond. We calculate that, given the new estimate of the pressure at the mantle core boundary, and knowing that Mercury is also a carbon-rich planet, the carbon-bearing mineral that would have formed at the interface between the mantle and the core is diamond, not graphite. Team member Olivier Nemours, an associate professor at the KU Leuven, told Space.com. Our study uses the geophysical data collected by the NASA Messenger spacecraft. The Messenger, Mercury surface space environment geochemistry and ranging, was launched in August 2004 and became the first spacecraft to orbit Mercury. Think about how little we paid attention to Mercury. The mission, which ended in 2015, mapped the entire tiny world, discovering abundant water, ice, and shadows at the poles, and gathering crucial data about Mercury's geology and magnetic field. I don't know why I'm stumbling a lot tonight. I'm not completely back from COVID. Ah. All right. Scientists set sights on an asteroid larger than the Eiffel Tower as it skims past the Earth. Ramsey's mission to study 99942 Apophis, when it passes closer to the Earth than GPS and TV satellites in 2029. In 2029, okay, I already read that part of that. Sure. Until recently, scientists had feared could foreshadow a catastrophic collision. Ah, fun. Now researchers hope to scrutinize the asteroid as it makes its close encounter in an effort to boost our defenses against other space rocks. The European Space Agency has announced funding for preparatory work on the rapid Apophis mission for security and safety. Ramses. God, I love how much they go after trying to make this work. In some of these names, I will continue to say that. In which a spacecraft will be sent to the asteroid to glean information about its size, shape, mass, and the way it spins as it hurtles through space. The mission will also shed light on the composition and internal structure of the asteroid, as well as its orbits, and explore how the asteroid changes as it passes within 200,000 miles or 32,000 kilometers of Earth, about 1/10 of the distance from the moon. On Friday the 13th. Oh, sorry, April 2029. The flyby it does with the Earth is absolutely unique, said Dr. Holger Krog, the head of the ESA's Space Safety Program Office, adding that no asteroid is expected to come as close for a few thousand years, unless we like suddenly come across it like 2 weeks before it's like close, which has happened before. The flyby it does with the Earth is absolutely unique. Asteroid. Sorry. If the sky is clear, you should be able to see it with your naked eye. I don't like that. I don't like that at all. The asteroid will pass closer to the Earth than geostationary satellites, including used for TV broadcasting, navigation, and weather forecasting. At that distance, Craig said, the asteroid will start to interact with the Earth. I don't like that either. It's the gravity field of the Earth that will basically slightly reshape the asteroid, causing it to change its form, he added. He said, adding the gravitational pull could also cause landslides on the asteroid's surface. So mini asteroids might, fly off from it. Did anybody think of that? Or at least debris from it? Craig said the insights from Ramses would help the scientists understand the asteroid and risk from space risk such space rocks pose. Our goal in planetary defense is not to do science on the asteroids, but we will do science on the asteroids. But it is to characterize them in a way that one day we can deflect them when they become dangerous, he said. Monica Grady of the Open University said that while most asteroids were in fairly secure orbits, it did not come near our planet. Earth-crossing asteroids such as this one were a different matter. They come near the Earth, and there's a potential that one day one of them will hit the Earth, causing a major disaster. We believe this happened 65 million years ago when the dinosaurs were all wiped out. I mean, there's been arguments about that one being the exact cause. And if it's a big asteroid and it hits us, it'll be a catastrophe which will destroy humanity. After its discovery in 2004, this asteroid kept scientists up at night with concerns it might collide with the Earth as it orbits the sun. While NASA ruled out an impact as it approached the Earth in 2029 and 2036, it was only in 2021 that experts said a smash would be off the cards. Smash or pass. We're off the cards for at least the next 100 years. However, space agencies are not leaving the security of the planet to chance, instead investigating ways of tackling Earthbound asteroids. Among such projects is NASA's DART mission, in which a spacecraft was smashed into the asteroid Dimorphos to test whether it could be possible to deflect a space rock. The ESA's Hera planetary defense mission, due to launch this year, will study the aftermath of that crash. But the DART experiment has showed that it's very important to understand everything about the target asteroid before you impact it, because the composition of its materials, spin rate matters, and the mass matters. So, in principle, before engaging with an asteroid, you need to be able to do it at a very fast inspection. Ramses offers scientists a chance to practice such a rapid reconnaissance. You cannot just go and hit a target asteroid, because you cannot predict the outcome. You have to make it, and you could make it worse. Professor Alan Fitzsimmons of the Queen's University in Belfast, who was on the science advisory team for Ramses, said the data collected by the Ramses mission could also help scientists extend the window for which they could predict potential collisions with this asteroid for many hundreds of years. Our descendants at the moment still have to worry about this thing, he said. Cragg says the new financing of Ramses would allow the team to buy the first hardware for the mission, although the final decision on whether Ramses will go ahead will not be made until the end of next year. Oh, goodness. As well as carrying an asteroid framing camera, Cragg said. Other potential instruments could include a seismometer to monitor activity as the asteroid experiences the Earth's gravitational pull. Should Ramses be approved, the plan is to launch the spacecraft in early 2028. Well, we better find somebody who can do it well. Oh, one of the articles I forgot to pull up was they're still stuck in space, by the way. Those two, let's see. The two astronauts that went on the Boeing Starliner, still in space. The plan is to launch a spacecraft in early 2028, so we have a little less than 4 years, which is very rapid for a spacecraft. Ramses is not the only mission preparing to scrutinize Apophis. Apophis. Excuse me, I don't know why I finally figured out how to say that. After NASA's successful OSIRIS-REx mission last year, which recovered a 4.6 billion-year-old chunk of space rock from the asteroid Bennu. And they finally, opened the... took 6 months to open the place where they stored it. The same spacecraft will rendezvous with Apophis in 2029 under the new mission title Osiris Apex. Apex, yeah. While Ramses will arrive at this asteroid before its close encounter with the Earth, Osiris Apex is expected to arrive afterwards. Dr. Tarek Daly of the Johns Hopkins Applied Physics Laboratory, who's involved with the Osiris Apex mission, said, what Ramses is going to be able to do is to document the asteroid before the close encounter with the Earth. So then Osiris Apex can really look and see what did this natural experiment do? How did it change this asteroid? Daly says the fixed date of the close encounter in the Earth is important. There's nothing we can do about it in terms of changing that date. That's what would happen in a situation where an asteroid was coming to hit the Earth. We can't negotiate with the asteroid. I mean, I'm sure hitting it pretty hard is considered in a negotiation. It's not a non-violent version of a negotiation. What we can do is prepare to respond in an effective way. Grady says that while such missions were interesting to scientists, they also held a wider appeal. It's very exciting as a member of the public to realize that we could actually do something about averting the Earth from catastrophic extinction. Yeah, except we do nothing about global warming. Woo! Alright. Curiosity. I feel like I've had at least one article about curiosity this entire time that I've decided to do. Check this out. Curiosity has cracked open a rock on Mars and found a huge surprise. A rock on Mars has just spilled a surprising yellow treasure after Curiosity accidentally cracked through its unremarkable exterior. When the rover rolled its 899 kilogram or 1,982 pound body over the rock broke open, revealing yellow crystals of the element cipher. Cipher, no swiping. Cipher from Final Fantasy VIII. Sulfur. Yellow crystals of the elemental sulfur. Brimstone. Oh, so hell is on Mars. Sorry. Although the sulfates are fairly common on Mars, this is the first time sulfur has been found on the red planet in its pure elemental form. What's even more exciting is that the Vallis channel, where the Curiosity found the rock, is littered with rocks that look suspiciously familiar. Similar to the sulfur rock, before it got fortuitously crushed, suggesting that somehow elemental sulfur may be abundant here in some places. Finding a field of stones made of pure sulfur is like finding an oasis in a desert, said Curiosity Project scientist Ashwin Vasavada of Vedia of NASA's Jet Propulsion Laboratory. It shouldn't be there, so now we have to explain it. Discovering strange and unexpected things is what makes planetary exploration so exciting. Sulfates are salts that form when sulfur, usually in compound form, mixes with other minerals and water. When the water evaporates, the minerals mix and dry out, leaving the sulfates behind. These sulfates can tell us a lot about Mars, such as its water history and how it is weathered over time. Pure sulfur, on the other hand, is the only forms under a very narrow set of conditions, which are not known to have occurred in the region of Mars where the Curiosity made its discovery. There are, to be fair, a lot of things we don't know about the geological history of Mars, but the discovery of scads of pure sulfur just hanging about on the Martian surface suggests that there was something pretty big we're not aware of. Sulfur, it's important to understand, is an essential element for all life. It's usually taken in the form of sulfates, and is used to make two of the essential amino acids organisms need to make proteins. Since we know about sulfates on Mars for some time, the discovery doesn't tell us anything new about that area. We're yet to find any signs of life on Mars anyways, but we do keep stumbling across remnants and bits and pieces that living organisms would find useful, including chemistry, water, and past habitable conditions. Stuck here on Earth, we're fairly limited in how we can access Mars. Curiosity's instruments were able to analyze and identify the sulfurous rocks in the channel, but if it hadn't taken a route that rolled over and cracked one open, it could have been some time before we found the sulfur. The next step will be to figure out exactly how, based on what we know about Mars, that the sulfur may have come to be there. That's going to take a bit more work, possibly involving some detailed modeling of the Mars geological evolution. Meanwhile, Curiosity will continue to collect data on the same. That area is rich in Martian history, an ancient waterway whose rocks now bear the imprint of the ancient river that once flowed over them, billions of years ago. Curiosity has drilled a hole in one of the rocks and taken a powder sampling of its interior for chemical analysis, and is now trundling its way deeper along the channel to see what other surprises might be waiting just around the next rock. Oh, riverbed? Not that? Alright. The James Webb Space Telescope finds a jeweled ring in the cosmos. A gravitationally lensed quasar looks just like a sparkling piece of jewelry. That's kind of cool. A sparkling jeweled ring created through a cosmic phenomenon called gravitational lensing has been imaged by the James Webb Space Telescope. The new image captures a distant quasar known as RxJ 1131-1231, which lies about 6 billion light years from the Earth. The powerful gravitational field of a nearby elliptical galaxy located in the foreground of the image warps the light of the quasar, which is an extremely luminous active galactic nucleus, creating a bright arc and duplicate views of the object, ultimately procuring a visual that looks like gemstones on a ring. Isn't that so cool, though? Quasars are powered by large amounts of gas and dust falling into a galaxy's supermassive black hole, causing the region to shine very brightly. I think it was last episode that we watched that simulation that they had of what it would be like to fall into a black hole. The effects of gravitational lensing, which occurs when a massive object like a galaxy bends the light from a more distant source, allowing astronomers to study regions close to the black hole of distant quasars, according to a statement from the European Space Agency. Measurements of X-ray emissions from quasars can provide an indication of how fast the central black hole is spinning, and this gives researchers important clues about how black holes grow over time, the ESA officials said in the statement. The elliptical galaxy created by the gravitational lenses in the new JWST image appears as a small blue dot in the center of the ring. The galaxy acts as a natural telescope, magnifying the light from the more distant quasar, which is otherwise too far away to study. If a black hole grows primarily from collisions and mergers between galaxies, it should accumulate material on a stable disk, and the steady supply of new material from the disk should lead to a rapidly spinning black hole. On the other hand, if the black hole grew through many small accelerated acceleration episodes, it would accumulate materials from random directions. Observations have indicated that the black hole in this particular quasar is spinning at over half the speed of light, which suggests that this black hole has grown via mergers rather than pulling material in from different directions. So, this is what they're talking about. So pretty. All right. Can black holes be created from pure light? A new paper challenges theory. Squeeze enough stuff into one spot, space-time itself will... I don't think I like the way this is written out. Squeeze enough stuff into one spot, space-time itself will pucker up in a sweet cosmic kiss known as a black hole. As far as Einstein's sums are concerned, that stuff includes the massless glow of electromagnetic radiation. Given that E equals mc squared, which describes the equivalence between mass and energy, the energy of light itself should, in theory, be capable of creating a black hole if enough of it is concentrated in one spot. Before you crack out the big gun lasers and punch some holes in the universe's floorboards, this tongue-in-cheek of this I like it, but I don't like the beginning, statements on this. There's one thing researchers from the Complutense University of Madrid in Spain and the University of Waterloo in Canada. I've been to the University of Waterloo in Canada. I've been to Waterloo in Canada too. Want you to know. It's something called the Swinger effect. Could make the whole thing impossible before you even get started. Einstein's general theory of relativity is a description of space and time distorting in relation to the presence of energy, such as that contained by mass. Putting enough mass in one spot and the distortion will become so extreme, nothing, not even light, will escape. Back in the mid 1950s, American theoretical physicist John Wheeler discovered there's nothing in Einstein's theory to rule out the possibility that energy within a sufficient concentration of gravitational or electromagnetic waves could warp space-time enough to keep those same waves trapped in place. He called this exotic object a gyeon, and it considered it a kind of hypothetical, highly unstable particle. Today, gyeons are a relic of an age of scientific musing that also gave us wormholes and white holes. Theoretical toys that tell us about the limits of mathematical models than they do about the physical reality. Yet another form of gyeon that Wheeler referred to as the Kegelblitz pops up every now and then in science fiction as a fantastic power source, German for ball lightning. These itty-bitty proton-sized black holes were proposed to form in the intense focus of incredibly energetic beams of light, such as futuristic high-power laser. While the general relativity gives the green light to Kegelblitz, the quantum physics is its doubt. So, theoretical physicist, I'm sorry, I'm gonna absolutely ruin this name. Velo, Verez, Dumin, Avero. I'm just gonna go with that. From the Complutense University of Madrid, and his team ran the numbers on behavior of electromagnetic fields as their energy rises to extreme levels. The quantum landscape is like a casino where waves of possibilities ripple constantly like a non-stop roulette wheels. Small bets rarely pay, but pile enough cash on any one table and you're almost guaranteed to win. What? Sorry, I don't do roulette. Similarly, a strong magnetic field in an otherwise empty space almost guarantees a pair of electrons and positrons will emerge from the quantum flurry of endless possibilities. In a paper that has yet to be peer-reviewed, that's something you should pay attention to when you look at this stuff, showed that this phenomenon known as the Schrödinger effect would prevent the formation of a Kegelblitz ranging in size from nearly twice the size of Jupiter down to a fraction of the size of the proton. In effect, piling all that light in one space would provide the necessary energy to form pairs of charged particles to pop up in existence and fly off close to the speed of light, preventing the growing dimple of space-time from ever developing a black hole defining event horizon. Our analysis strongly suggests that the formation of black holes solely from electromagnetic radiation is impossible, either by concentrating light in a hypothetical laboratory setting or a natural occurring physical phenomena. That's not to rule out the possibility completely. The researchers admit things might be different in the exceptionally extreme conditions of the early universe. Other forms of gyeons, such as those based in gravitational waves, remain a curiosity that could have also existed the nascent cosmic billions of years in the past. There are those who are banking on a Kegelblitz powered spacecraft to jet them to the stars. Now, might have to go back to the drawing board, however. Alright, the shape of the solar system has changed dramatically, scientists say. The shape of the solar system was once a little bit more on the doughy side. I forgot how coy articles I picked out these days, at least for this one. Before it arranged itself into a flattened disk, the distribution of dust and rocks had more in common with a donut than a pancake. The everything on a donut, yeah. Or like, what was it, that really good Existence of Everything and Nothing at the Same Time? That really cool film. This conclusion scientists reached. Oh, I'm sorry to hear that. I've had to rig many chairs to properly sit on. Cause I move around too much, and apparently they can't take the twisting and me shifting my weight so much at different points in time. Rocking. This is the conclusion scientists reached after studying iron meteorites from the outer solar system, finding that they can only be explained that the solar system's shape was once to toroidal. In other words, like a donut or bagel. The formation of a planetary system around a star. I want bagel now. Nice. I'm sorry, I realized I forgot to actually turn off ads again. I am sorry. The formation of a planetary system around a star starts in a molecular cloud of gas and dust drifting through space. If a portion of the cloud becomes dense enough, it'll collapse under its own gravity, spinning as it goes, becoming the seed of a growing baby star. Yeah, that was oh god. My mind's having a moment. I don't know why I'm not completely awake right now. Um the Legend Soul. Yeah. Within the disk that smaller clumps form. Oh wait, yeah. It spins the material surrounding cloud, pulls into a circular circling disk that feeds the protostar. Within the disk, smaller clumps form, becoming protoplanetary seeds that either continue to grow into full planets, or what seems far more frequent, have their development arrested, remaining as smaller objects like asteroids. Arrest in development. Party har har. We see these disks time and time again around other stars, with gaps carved by planets slurping up the dust as they go. Yeah, I really appreciate Legend Soul for all the gifts that they gave. But the iron meteorites found here in our solar system tell another part of the story. According to a team led by planetary scientists Bin Dong Shong of the University of California in Los Angeles, the composition of asteroids in the outer solar system require the cloud of material to be donut-shaped rather than a series of eccentric rings in a flat disk. This suggests that the first stages of the system's coalescence were toroidal. The iron meteorites in question, chunks of rocks that have made their long way to the Earth from the outer solar system, are richer in refractory metals than those found in the inner solar system. Well, I appreciate that, hun. I try. That's the key of the matter. I try. Can't say I do it well half the time, but I mean it's there. Now I'm gonna stop blushing over here. Keep reading. These metals, such as platinum and iridium, whose formation can only take place in very hot environments, such as one closest to a forming star. This poses a bit of a pickle because those meteorites came not from the inner solar system, but the outer, which means they must have formed close to the sun and moved outward as the protoplanetary disk expanded. According to the model constructed by Zhang and his colleague rocks, though, these iron objects would not have been able to traverse the gaps in a protoplanetary disk. According to their calculations, the migration could have occurred most easily if the protoplanet structures were donut in shape. I'm just going to go bagel in shape. I'm going to make this very, very unscientific on how I'm going to, instead of trying to say that. This would have ushered the metal-rich objects toward the outer fringes of the forming solar system. Then, as the disk cooled, the planets started to form. The inability of rocks to travel across gaps in the disk would have acted as a very effective fence, keeping them from migrating back towards the sun under the pull of gravity. Once Jupiter formed, it is very likely opened a physical gap that trapped the iridium and the platinum metals in the outer disk, preventing them from falling into the sun. Zhang says, these metals were later incorporated into asteroids that formed in the outer disk. That explains why meteorites formed in the outer disk, carbonaceous chondrites and carbonaceous type iron meteorites have much higher iridium and platinum contents than their inner disk peers. It's amazing what you can learn from a lump-pitted metal rock. Let's look at it again. Also, doesn't look like it's fun to be bludgeoned by, but that was just a thought that occurred to me. Not that I'd bludgeon anybody with it. Yeah, I'm trying to make sure that I have them in the right order. I think this... yeah, this would be the last one, I think, that would count within this. Actually, that might actually be better than pull it back over here, but we're going with this. Astronomers reveal stunning image of baby star coming into existence. Whatever the James Webb Space Telescope looks into space, matter and energy are interacting in spectacular displays. That's kind of cool looking, don't you think? The Webb reveals more detail in these interactions than any other telescope because it can see through the dense glass and dust that cloak many objects. Yeah, it's also on the other side of the moon. I know, and I hate jellyfish. I mean, I love looking at jellyfish. Please don't get me near them. I jumped when I was 12 years old. The last day, afternoon, like evening, I guess is a better way to put it, of the trip to the beach down in Gulf Shores. I jumped into an entire jellyfish. They were all dead, but they were together, and you couldn't see them from the way the lighting was. And I ran out screaming. That's an experience I'd never wish on many people. Actually, I'd never wish on anybody now that I think about it. What if it is a giant jellyfish? Oh, I mean, we can do the SpongeBob thing of, except they're in space. By the way, do not do what my parents did, because they did not know any better. They picked me up and put me back in, they put me in the shower. Which, makes the tentacles reactivate because of the water. Just saying. What is it that you need again? I forgot. Um, but Well, that was back when I was younger, like 12. Um, Let me see. Yeah, this is the first thing that lists on the clinic. Number one, wash the tentacles and venom off an affected area of your body with seawater. Do not use fresh water. They put me in a fucking shower in the hotel we were at. Use tweezers or gloved hand to remove any tentacles you see on your skin. They did not do that. Apply vinegar or rubbing alcohol to the affected area to stop any more firings of nanocysts. They didn't do that either. And I don't know why. We didn't go to the emergency room. I think I don't know if there was an argument about the price of an emergency room on why we didn't fucking go to an emergency room. I don't know why. I was kind of not paying attention to anything that was happening around me other than pain. But we went. I think we went to like a Doc in a Box. I think, and they basically told us to go get some vinegar. Uh, to put on it, and they had some. I don't know if it's part of my memory or not a part of my memory. But the people at the clinic refusing to actually, they have a specialized medicine to get, like, pour on you, and they didn't want to pour it on me. Um, so I was basically stuck in the car in pain until my parents went to the store and bought the stuff. Um, but yeah, I still went back into the water the next morning, by the way. I was a little bit nervous, but I refused to be afraid of the water. Ever. I'm a water baby at heart. Anyways, in a new image, the space telescope spots a young protostar only 100,000 years old. The star is named L1527, and at this young age, it is still ensconced by the molecular cloud it spawned, so the jellyfish look. This is one of the reasons why NASA built the JWST skeleton. With the help from the European Space Agency and I don't remember what CSA is. I'm having a moment. The telescope can see through dust and gas to reveal the earliest stages of the star formation. This image was captured with the MIRI, the mid-infrared instrument. The young protostar is at the heart of it all. It's still glowing, and it's still glowing. It's accumulating mass from the protoplanetary disk that surrounds it. That we just, like I said, read aloud in the article about it maybe being like a donut shaped thing. And that kind of, if you look at it, that doesn't look like as much of a disk. And even though we're doing it on like a 2D environment looking at it, you shouldn't assume that it's like just a 2D when you're in the space itself. The disk is a tiny, dark horizon line at this image's center, so that. The protostar isn't a main sequence star, so it's not undergoing fusion like the sun is. There may be a small amount of deuterium fusion at its core, but it generates energy in a different way. As the star's gravitational power draws material nearer, the material is compressed and heats up. More energy comes from shock waves generated by incoming material than collides with existing gas. This is the energy that lights up the star and its surroundings inside the giant molecular cloud that it spawned in. As young protostars accumulate mass, they generate powerful magnetic fields. Combined with the star's rotation, these fields drive matter away from the star. Well, each beach, by the way, has its own kind of look to it. And some beaches are just not as fun to be at. I will put it that way. And usually when it's crowded, I guess more of a touristy beach, I don't like. I like wild beaches. Woo. All right. But don't. Shh. Yep, absolutely. Draw near. All right, where was I? Accumulate mass. As young protostars accumulate mass, they generate powerful magnetic fields. Combined with the star's rotation, these fields drive matter away from the star. So, as a prototype star acquires mass, it also ejects some of it back into space in spectacular hourglass-shaped jets. No, we call them jellyfish. That come from the star's poles. These jets create visible bow shocks in the matter around the star, which are the filamentary structures. These polycyclic aromatic hydrocarbons in the star's environment. They're organic components abundant throughout the universe that may have contributed to the appearance of life. They glow blue in the image, including the filamentary structures. The red regions in the center is a thick layer of gas and dust surrounding the young star, lit up by the star's energy. The white region between the red and the blue is a mixture of materials. There are more polycyclic aromatic. Polycyclic. Polycyclic. Ugh. Here as well as ionized gases like neon and other hydrocarbons. This isn't the first time this telescope is examined. L1527. In 2022, it observed the protostar with its near-infrared camera. Look at the difference between the two. It's 2022. And this is it now. Or is it, this one's just a closer look of it? Oh, it used a different one. The first one's a mirror and the other one's near, if I remember correctly. Yeah, the mid-infrared instrument. And this one's the near camera, which is the near-infrared. It's a beautiful display of matter and energy interacting in the is transcendent. Yeah, that is gorgeous, isn't it? Over time, the protostar's powerful outflows will clear its surroundings of much of the gas and dust, though it'll still have its protoplanetary disk. Eventually, the star will become a main sequence star, easily seen without the veil of gases and dust. By that time, the star's planetary system will also be taking shape. There are unanswered questions about protostar formation, and one of the telescope's main science goals is star formation. For example, astrophysicists don't know exactly how and when fusion is triggered, and a protostar becomes a main sequence star. Though astronomers know that there are powerful magnetic fields around protostars, they don't know exactly how they form and what role they play in the star's collapse and rotation. The telescope has made some headway on this question, and it recently confirmed that the jets from young stars are aligned because of the star's rotation and magnetic fields, something that's supported by theory but not confirmed by observations until now. There is also uncertainties about how binary stars form. Do they form the same way solitary stars do? Why are so many stars binaries? The exact nature of the events that trigger star formation is also unclear. Shockwaves from a supernova can trigger starbirth, but what about in other cases? Is it just a matter of density? The answers to these questions will be incremental. With its ability to see more detail in the young stars and the swirling gas and dust that enshroud them, the telescope is making progress one image at a time. Well, aren't most star binaries like one's a red dwarf and the other one's something else? Could it be just the materials that form is more likely to go towards one than the other? Yeah.